Hi, I'm Stryker Waddell, I'm entering my sophomore year for electrical engineering here at University of Arkansas. I'm interning at the National Center for Reliable Electric Power Transmission, or NCREPT. Here is Pearl. It is one of the WOW demos, or Wonders of Wattage demos. These were all built by high school students, and we take them to either elementary schools or other schools to show them electrical engineering. They were all built here in NCREPT by students, for students. So for this machine to work, it needs direct current, or DC. However, the problem is the average outlet only runs alternating current, or AC. So as a way to switch from AC to DC, we have a rectifier. The house outlet, or the AC, is plugged into the rectifier, emitting the DC, or the direct current, which goes straight into the machine. And then with the first one is the capacitor. The DC then carries into the capacitor. The capacitor acts as a cup of water, filling up and then dumping out once it's completely full. However, the capacitor has two plates, a positive plate and a negative plate. The positive plate charges up and then discharging into the negative plate. Between it charging up and discharging is the potential charge, also known as voltage, which will be represented on the voltmeter right here. So once the discharge goes into the circuit, the next part of the circuit is the inductor. As we learned, the capacitor deals with voltage, the inductor deals with current. Current is the active flow of charge through a circuit or a wire. This is the inductor. The current goes in this end and out this end. It goes around the copper wire every single time. The flow of current through a copper wire wrapped around like this creates a flux in the magnetic field. To understand the flux of the magnetic field and the force of this is to show the right-hand grip rule. The right-hand grip rule is a great way to determine the direction of magnetic field of a solenoid or inductor. You take your hand, your right hand, you grab the solenoid, you curl your fingers around in the direction of the conventional current flow of positive to negative like this. Your thumb will indicate the north pole of the magnetic field. As you can see with this inductor inside of here, the current flows like this, so the north pole of the magnetic field of this inductor is straight up. As you can see from this image, you can see the field lines of the magnetic field. This design uses electromagnetism to accelerate a ferromagnetic object. A capacitor is charged and suddenly discharged, momentarily creating a magnetic field which attracts the ferromagnetic object to the center of the coil, where the magnetic field is strongest. The magnetic field disappears, thus the object's momentum is preserved without being pulled back by magnetic attraction. Now that you understand every single component inside of Pearl, now you have to turn it on, which is the switch. You can see that it's turned on through the LED, showing that the power is going through it. Now that you have it turned on, you can press this button, which charges the capacitor full of charge, which then is dumped out into the inductor. As I press the button, you can see the voltmeter filling up with charge. So when I hold it down, it'll fill up all the way, and then the pellet will shoot up. However, if I don't let it charge up all the way, the pellet will only go about halfway, like that. So that is how Pearl functions. Pearl is a great way to understand different concepts that involve electronics and physics. Electronics concepts such as the capacitor and the inductor, and physics concepts like the right-hand rule. This is a great way to understand concepts of engineering and science. Follow for more content.